Hello everyone. In this video we are going to talk about the second law of motion or the second law of Newton. But before that, let's have a short and quick review on the first law of Newton. So the first law of Newton or the first law of motion was about if an object is at rest and there is no force acting upon that, the object will stay at rest forever. Or if an object is in motion and is not acted by any unbalanced forces, it will continue its motion with a constant velocity forever. So in the first law of motion, the net force was equal to zero. It means there was no unbalanced force acting upon an object. But the second law of motion, there is an unbalanced force. So in the second law of motion, sigma f or net force is not equal to zero. So to understand the second law of motion, let's imagine two masses, two objects with different masses. Let's say m1, mass 1, let's say, is 2 kilograms, and the other one is a huge mass, like much larger than the first one, which is, let's say, 20 kilograms. Now the question is, if we apply a force upon this object or the first mass with the magnitude of let's say 1 Newton, okay, suppose it's frictionless, both objects are on a frictionless surface, then what will happen in M1? In this case, we know that the object will start accelerating. So the object starts moving and it starts accelerating. So if we apply the same force, 1 Newton, to the second object, which has a larger mass, we would assume that it will start accelerating, but there is a difference between the acceleration of mass 2, m2, and m1, and without the both of them would have the same acceleration. So we assume that there is a difference between these two acceleration, and we think, based on our common sense, we think like this mass would accelerate faster because it has a smaller mass. And this assumption is actually correct because the second law of motion says, or the second law of Newton, if we apply a force on an object, okay, the object will start accelerating, which this acceleration is directly proportional to the net force acting upon that object and inversely proportional to the mass of the object. It means that the same example that we discussed. So if we want to write it mathematically, we can say acceleration here, which is a vector, is equal to net force. It is directly proportional to the net force because more force, more acceleration. And inversely, it is proportional to the mass. So in this case, if the force is large, the acceleration will be large. And if the mass is large, the acceleration will be small because they are inversely proportional. Now let's have a look at this example. A force of 500 Newton acts on a load of 250 kilograms, which is at rest in a space, as shown in the figure below. Okay, so find the acceleration of the load and the speed which the load or the mass reaches 5 seconds late. So in this case, we are going to find out the acceleration. So part A, we will write acceleration is equal to sigma F, or net force, over m, or mass. But in order to calculate sigma F, we need to pay attention to take into account all the forces acted upon this mass. So in a space, when it is in a space at rest, there is no gravity. Okay, there is no gravity, so we don't have gravitational force. And when the force acts on this object, there is no friction. There is no air resistance. So therefore, the only force acting on this object is 500 Newton. Therefore, it will be 500 Newton divided by 250 kilogram, which will be equal to 2 meter per second squared. So this is part A. Part B, we are supposed to calculate the velocity of this object after 5 seconds, when it reaches 5 seconds. So therefore, in this case, we have acceleration because the force is not still removed. The force keeps acting on this object till 5 seconds. So therefore, we will use the fast kinematic equation, which says that final velocity is equal to initial velocity plus acceleration times t. So v final, which is our v 5 seconds in this case, we are looking for this velocity. So v final will be equal to, and initial velocity in this case, or initial speed in this case, since the object was at rest, so therefore the initial velocity will be equal to 0. 0 plus 2 meter per second squared times 5 seconds. So will be equal to 2 times 5 will be equal to 10, but we won't forget to do dimensional analysis. So therefore the velocity will be equal to 10 meter per second. That's it. And part C says if the force is removed 5 seconds after its motion starts, what will its motion be? So in this case, the motion will be a uniform motion, because when the force is removed based on the first law of Newton, this object will continue moving with a speed of 10 meters per second forever. So that will be the answer to part C. Now let's solve the other examples. Mass, we have two masses, and there is a force acting on mass number 2 or M2, 3 kilograms. So we want to find out the acceleration of the system because there are two parts, so we call this as a system. So in order to find out the acceleration, we need to apply the second law of Newton. But here there are some points we need to pay attention to. First of all, these two objects are on a smooth horizontal surface. So when we say smooth, it means there is no friction, or frictional force here is equal to 0. So in this case, we are supposed to apply free body diagram for each part. So in order to apply free body diagram, the first step is to draw gravitational force, which here is mg, which is 3g, and we have normal force, and here we have tension force, because tension force is a pulling force, is not pushing, is pulling. So therefore it is outward from any object. So here we have the same T, or tension force, and again here we have mg, m1 mg, and this is m2 mg, which is equal to 2g, and then it has its own normal force. So now let me just divide this system into two parts, and then one by one apply the second law of Newton. So here, for object mass 3 kilograms, or M2, we apply the second law of Newton. We say sigma F is equal to ma, and here is sigma F, since we don't have any friction and we are talking about the horizontal motion, since the forces towards y-axis are cancelling out each other, therefore the object and the direction of the force is horizontal to the horizontally, so therefore the motion is only towards x-axis. So we will analyze this motion based on the x-axis only. Therefore here sigma F will be equal to 10 Newton, which is towards the right, or due east. So it's positive, it's not negative. And then we have a tension force which is heading to the west, or due west, or to the left. Therefore that is negative, and this is sigma F, so is equal to ma, and m here is 3 kilograms, and acceleration times acceleration. So okay, this will be our first equation, and then we will apply the same thing to mass 1. So again we say sigma F is equal to ma for mass 2, and in this case we will look at the horizontal forces, or towards x-axis, upon this object, and there is no force but tension force. Tension force is equal to ma, which here m is 2 kilograms times a. So this will be our second equation. So please notice that since the system, they move together and they are connected with this piece of rope or chain or whatever it is. So the acceleration of m1 is equal to the acceleration of m2. Therefore, the acceleration here in equation number 1 is equal to the acceleration in equation number 2. The same acceleration. So here we have two equations and two unknowns. So we say 10 Newton minus T is equal to 3 kilograms A, and then here we have T is equal to 2 kilograms times A. We just need to add them up, and then we will get 10 Newton is equal to 5 kilograms times A. Therefore, the acceleration of the system will be equal to 2 meter per second squared. So this is part A. And part B, we are supposed to, so part A is done. Part B, we are supposed to find the value of tension, which we simply plug in to the formula number 2, equation number 2. So then part B will be tension force is equal to 2 kilograms times 2 meter per second squared, which will be equal to 4 newtons. And this is the tension force. And tension force in acting on object or mass 1 is equal to tension force in mass m2 or 3 kilograms. And the reason is because this force is transmitted through the same rope or the same string. Now another example, we have this system now. A frictionless system consisting of masses m1 and m2 is released from rest. Find the acceleration of the system. So here in solving these kinds of problems, we need to pay attention to the direction of motion. So the direction of motion will be towards down, and this object will pull the mass m2 will move the mass m1. Therefore, the system will start accelerating. So the first step to find out the acceleration is we need to apply the second law of Newton. So we write it in this format. F is equal to ma. We just rearrange the original equation, which was net force over mass. We just rearrange it to make it easier, more convenient. Okay, anyway. Now, let's one by one, each part of the system apply free body diagrams. And so we will start with M2. We have a mg, m2g, let's say. And then we have a tension force. We don't have any other forces. We don't have friction with the wall. So let's move to and we don't have any normal force because it's not in contact with the wall. So m1g and normal force and T. So again, in this case, since normal force and mg are equal, and the reason is because they are in a horizontal surface. So if they are not in a horizontal surface, they will not be equal. But in this case, because it's horizontal, so mg and n, or normal force, are equal, therefore they will cancel out each other in our vertical analysis of the forces, or sigma Fy. So therefore we just pay attention to or focus on the analysis of the forces towards x-axis. All right, so again this one is frictionless, so we don't have any friction, no friction, or frictional force is equal to 0. Again, we will apply the second law of Newton one by one to each mass or each object. Alright, so let's start with object number 1, or mass number 1, which we say sigma F is equal to ma. So therefore, then the only force acting upon mass 1, or 3 kilograms, will be tension force, because we don't have any friction. So tension force will be equal to 3 kilograms times A. And for the case M2, since mg should be larger than tension force, because the system is accelerated, so therefore mg, or the gravitational force acting upon mass 2, or m2, must be larger than t. So therefore m2g must be larger than t, because the system will move or accelerates. Therefore, here in this case, sigma F will be equal to mg, or m2g minus t, is equal to m2a, or acceleration. So if we substitute the numbers in the equation, so we can say 1 m1 m2 is 1 kilogram, and g here is 10. So therefore it will be 10 newtons minus t is equal to a. Now we have two equations, equation number 1, equation number 2, and then we can simply find tension force here, or acceleration. So let's just write these two equations here. So in this case, we just add them up. So here will be 10 newtons will be equal to 4, and here is 1 kilogram actually, 4 kilogram A, or acceleration. Therefore the acceleration will be equal to 2.5 meter per second squared. So this is the acceleration of the whole system. So now the part B says find tension force. So tension force, we just simply part B, the easiest equation is number 1. So we can say T is equal to 3 kilograms times 2.5 meter per second square will be equal to 7.5 newton, and this is the tension force.